In this video, we are going to understand about area of sector. Now, just to recall, if suppose there's a circle here, let's call the center as O. If there are two radius, let's call this as A and B. Okay? So what will happen is that this portion which is covered by OAB is called a sector. Okay? An area of such a sector, how do you calculate it? Now in a circle, you know that all the points on the circle are equidistant. Okay, so area of sector of a circle is equal to, let's say, the angle which is here within this sector is theta. Then area of a sector of angle theta is equal to theta upon 360 degree. Now you must be wondering why 360 degree? This is because one complete circle in an area circle is equal to 360 degree, right? So if this is a part of that 360 degree, then obviously I need to proportionate it into area of a circle. So you take the proportionate area of a circle while comparing this theta, which is the angle formed by the sector, vis-a-vis the total angle at the center of the circle. Or in other words, this is equal to theta upon 360 into pi r square. Right? Now, let's say we join A and B. Okay? So once you join this A and B, this area is there. And you also have an arc AB. Now let's say, suppose you have to find length of arc AB. Okay? What will be the length of the arc AB? Now, you know that if you have to cover the entire distance of a circle, suppose you start moving from this direction, you move this, you do this. This length of a circle is what? Its circumference, which is what? 2 pi r. Again, this 2 pi r length is for this entire circle, right? So if suppose you are forming a sector with the angle of theta again, then you have to apportion this 2 pi r also. So the length of the arc, which is this portion, is nothing but theta upon 360 degree into 2 pi r, which is nothing but the circumference. Okay, so here you apportion the area, namely pi r square. Here you apportion the circumference in the ratio of this angle which is formed by this sector vis-a-vis 360 degree. Right? Now, suppose someone was to ask you, in this case, what is the area of this green portion? Obviously, area of segment, what do you call it now? Let's say you call it as AB. Okay? The area of this segment is basically what? It is equal to area of sector OAB, which is this area, minus the area of this triangle. Right? So this is basically some of the concepts which are going to work for you as you move forward with the questions relating to area of circles.